The document I've created, which is a little cheat sheet for week 4. It's got our bonds section here and then a share section. So this first part of the video, I'm just going to go over bonds and show you how that's all done. And we're going to do the questions over here of questions 3, 12, 13, and 14. So I've done all the calculations there, but I just really want to walk through it with you. So a bond is a type of debt. There's usually a payment right at the end and they're fixed every single month. So what we've got is, this is for our manual calculations. You can see our PV. So to get our PV of a bonds, we do the PV of the final payment. So this is what we would use, so blue and blue. So that's our general PV calculation. So if we have a face value of $100, we would use that here to calculate. And then we have the PV of the cash flow payments. So between, if we had a life of a bond of say 8 years, that would be our 8-year cash flow, and then that would be our final face value payment of whatever it may be, which is generally $100. So that's how we calculate it long form. Now, it's so much easier to use our financial calculator. In the prior weeks, you've already learned how to input this all into your financial calculator with your general PV formulas. So this is super easy. I wouldn't be doing it your long way. I would be doing it your financial calculator. So that's what I'm going to show you today, and I'll actually show you some examples of using it so you can see how you input it. I've given you a bit of information here. Something important to mention is here, face value, par value. So that's where you're going to see up here, this little portion here, so your final payment. In some of the questions, you're not really given the information of how much it actually is, but if you look here, if you're not given anything, use $100 as it's a usual denomination. I've given you a little Investopedia link here if you'd like to read more information about why that is, but just generally use $100 to keep it easy and simple. What else have I got here? I've got how you calculate your coupon rate. You'll see that in one of the questions. What face value / par value kind of is, and yield to maturity down here, which is your market interest rate. Okay, so this is a bit of information. We will be calculating this. Again, I said if you're not given the par value or face value, use $100. I've said here it's best to use your financial calculator. You'll see why. When we're calculating the yield to maturity, you'll just go comp I on your calculator. Rather than doing, if you use manual calcs and you're using this, if you're calculating yield to maturity, it's the R you're trying to find here. You're going to have to do trial and error. There's no simple formula to calculate that. So again, use your financial calculator. All right, let's jump into it. Here are our questions that we've been requested to go over. And I'm just showing you, again, as I mentioned, I'm just showing you how to use your financial calculator because this is what you should be doing in your exam. So let's have a go at question number 3. So you've issued bonds, sorry about that. Issued bonds have a price of $91.70 and a coupon rate of 10% paid annually. The bond will mature in 6 years. What will the yield to maturity be? So here, as I said, that's what we're calculating. We're calculating the I portion. So in your financial calculator, you go comp I. So as we're not being told what our face value is, so that is negative $100. Our PV, we're told, is $91, our N is 6, and our payment is 10%, which is our coupon rate of the face value. So if we jump back into this, if we're not given the payment amount, the payment can be calculated by the coupon rate times by the final payment. So that's important to know. Okay, so here we go. There are all our calculator inputs, and you input it in and you get 12%. So I've just put in that little note about the $100. What we're going to do now is flip over into the financial calculator, and I'm actually going to show you how to input that. So here we go. Okay, so video for question number 3. So we're going to show you how to calculate it. Obviously, clear the memory. Okay, then we're going to enter our P, which is 91.77 PV, and then we've got 6N. Now we need to do a negative 10 for payment, negative 100 for future value. Then we need to calculate our yield. So we go comp I. That's calculating and 12% there. So again, we are now calculating the PV. So we're using the exact same formula as question number 3. Same, well, obviously different inputs, but we're calculating the PV amount. So we've got bonds of a coupon rate of 6%, mature in 6 years, assuming semi-annual coupons. So that means 2 payments per year. What is the value of the bond? The similar bond yield is 5%. So we know our interest rate is 5, but we have to divide by 2, so we get I is 2.5. Our N, we have to times it by 2, because it's semi-annual, so we've got 12. Face value, we're not given it, so we use 100. And then we've got our payment, so we've got our coupon rate, divide by 2, so that equals 3%, times by 100, which equals a negative $3 payment. So you input that onto your calculator, you calc for PV, comp for PV on your calculator, and you'll get $105.13. Now I made a little note here. So our PV is greater than the face value, so that means it's a premium bond. Okay? So if we jump down to question 13, actually before we do that, let's jump over and I'll actually show you how you input that all into a calculator. Alright, so we clear our memory and let's do question number 12. So remember, this question is semi-annual, so we need to divide the interest rates by 2 and the N we times it by 2. So we've got interest rate of 5 divided by 2, so that equals 2.5. There we go. Our N is 12. Pop that in. We do negative 100 for face value. Remember, if we're not given the face value, we use 100, or par value. We always use $100 because that's generally what's used the most. And then our payment, so we're told it's 6%. We divide that by 2, which equals 3%. To get our payment amount, we do our percentage of 6%, so that's our coupon rate, so sorry, 3%, because we're dividing it by 2 and timesing by our $100 face value. So then we've got $3, so we go negative 3 is our payment, and then we want to comp PV, which is $105.13. Okay, so now we'll go to question 13. I'm not going to go into detail, it's exactly the same question, but they're changing the bond yield from 5% up here to 8% down here. So all that's changing is our interest rate here of 8%. So 8 divided by 2, again, it's still semi-annual, equals 4%. We input all that in and we comp PV and we get $90.61. Now, PV is less than the face value, so we know that it's now a discount bond. Okay? All right, let's go down here to question 14. We're going to figure out the coupon rate. So, Slippery Slope has outstanding debt issue that currently sells for 90.06. So we know our PV here. The yield to maturity is 8%, so that's our interest rate here. And the bond matures in 7 years, so that's N. Assuming that the face value is $100, there we go. With the annual coupons, what's the coupon rate? So if we look at here, all our inputs, we don't know what our payment is, okay? So up here, that's what we're missing. So we input all that data and calculate our payment. So our payment is $6.09. Okay, let's put a little dollar sign. Now, here, I've made a note here. Your coupon rate equals your annual coupon amount, so that's going to be your dollar amount over your face value dollar. So from that payment, we can actually calculate the coupon rate. So coupon rate, here we go. Here's our formula again. So what we do is we do $6.09 over 100, which equals our coupon rate of 6.09%. There we go. So that's how we calculate it all. So you can see we're using the one formula and we can interchange it all to calculate all the different nuances. So it's just important to understand how they all feed into each other. Exactly what I mean is how would we extract the coupon rate out of this question. It's because we know that we can get the coupon rate out of the payment amount. So you just really need to understand how to apply that all, and hopefully this little document here, very short but sweet, should give you all that information. Remember, use your financial calculator here. Video is covering shares, so chapter 4 we're doing bonds and shares, so this is the share portion. What I've done is created a table for you, in order to really see how this is all applied. So it's a really easy way for you to locate the formulas. Not going to go through it all in video, but what you do is when you read through questions like you'll see upcoming, you can then figure out, hey, is this a zero growth? Is it constant growth, non-constant growth? And then we need to figure out how to apply those formulas. So if it was, if it said, constant growth at 8%, we know to go here. If it said that our last dividend payment was 50 cents and it's going to increase by a growth rate of 8%, that means we know we need to increase our first dividend, and we can go here and grab this rate here. If it said that it's a zero growth dividend, we can just go up here and grab this formula. So hopefully this is a bit of an easy way to access it. Obviously in your exam, you're not allowed to bring this in, you need to know it, but you can kind of see how all the formulas are very similar. Okay, I think through practice you'll get a really clear understanding of how and when to apply it all. So hopefully that helps a lot. Just seeing down here, what I've done is shown you a quick table here on how to apply the constant growth rate. So that might assist you in terms of understanding when to calculate the PVs at different years. I've also included down here calculating return on dividend and also the dividend yield calculation. So I think if you keep playing around, you'll see that all the questions are actually very similar. You're just interchanging. There are no financial calculator shortcuts for this. This is something you will need to know the formula for. So practice, 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 and lots of algebra. So let's jump into the questions and go through those now. Let's have a read. Pepper currently sells its shares for $4 per share, so there's our PV of $4. The last dividend, that's important to say last, was 30 cents per share. A little note there, because it's our last dividend, when we do our calculations, we're actually going to have to apply the growth rate to get our current dividend. The dividend expected to grow at 5%, there we go. We're going to do what's the required rate of return on Pepper shares. Now, we're going to need to do some algebra, and I'm going to show you, really break it down how we calculate that. So I've made a little note here in italics. So we have a constant growth ongoing. So if we go back to our document, we have a constant growth and it's ongoing, and we need to increase the value of the dividend. So we're going to take this formula here. So that's the formula we're working. The R is our unknown, and that's what we're trying to get. So let's start inputting and see where we get. So $4 is our PV, our dividend is 0.30 times by 1.05 over R minus the growth rate of 0.05. Okay, what I'm going to do is break it down very, very simply to show you how we do it. So in order to isolate R, what we need to do is we do the opposite formula in order to bring it across. So the first thing we're going to do is we're going to bring this R part. So we need to keep these two together over on the $4 side. So it's got a divide. So what we do is we do times. R minus 0.05 equals 0.3 times by 1.05. What's that? 0.315. Now we need to still do some isolation. So what we want to do is we want to get that 4 on the other side. So it's a times, now we do divide. So all of a sudden we've got R equals, R minus 0.05 equals 0.315 divided by 4. Okay, so then what we can do is, let's calculate that. 0.07875. Now, we want to get that R now by itself. We've released the brackets so we can do the opposite formula. So that's a minus. What we do is we bring it over and do a plus on the other side. So now we've got R equals 0.07875 plus 0.05. Okay, then we can do that. So it's going to equal 0.12875. Oh, should be an 8 there, which then equals 12.87. We round it up to 88% to 2 decimal places. So there we go. That's a very long-winded on how we calculate the required rate of return by using algebra. You can see what we do always is we do the opposite side of the formula, and we're trying to isolate the unknown value. So there's that. Yield, what we can do, we can go back to our spreadsheet. We've got our little dividend formula. It's super simple, which equals our dividend. Now remember, we have to increase that by the growth rate. So we've got 3 times by 1.05, divide by 4, which should equal this amount right here, which equals 7.875%. So there we go. That's how we calculate the last question to cover here. So let's have a read. Suppose that shareholders just paid $4 per share. So that is our PV. I've already made a mark here. For Frankly company shares, the share price will pay 20 cents per dividend in the upcoming year. So we know it's upcoming, so we don't actually need to increase it by the growth rate. So our dividend is 20 cents. Annual growth rate is 8% here, and we need to calculate the annual required rate of return. So we're going to use our little table that I created. We know that it's constant growth, and we know that we don't need to increase our dividend price. So let's flip over. So we go here, we don't need to increase our dividend, and it's ongoing growth indefinite. So here's our formula. So let's bring it down here. So what are we trying to find? The rate. There we go. Oh, we're going to bold that. So that's what we're trying to find. So we know that PV is $4. Our dividend is 0.2. And we know that we go R minus growth rate of 0.08. So I'm going to show you really long form in how to isolate that R and calculate the rate. So again, in order to flip it, we need to do the opposite calculation. So what we're going to do is flip this, and how do we do it? It's divides here, so we times it on the other side. So let's go 4 by brackets R minus 0.08 equals 0.20. So next step, we want to try and keep isolating it. So we're going to take that 4 times and divide it on the other side. So now we've got R minus 0.08, which equals 0.2, divide by 4. So then we can figure that out, do that calculation, which equals 0.05. So now we can actually isolate R. So we can bring the 0.08 onto the other side of the equation, but it's a minus, so now we plus it. So this is what we would be doing. R equals 0.05 plus, there we go, 0.08, which equals 0.13, which equals 13%. So you can see with algebra, when we really break it down step by step, and we know we just need to do the opposite equation on each side to isolate R, it's not as challenging. It's just in those answers, they really skip through. I wonder if I can show you. So here's the answers for that. They're not really explaining it. So when you really walk it out, you can see how we isolate that R. Anyway, thank you.